All right, this is going to be an application of being able to find the indefinite integral. So what we will do is a series of steps, and these steps will work for just about every problem that we do. And the first thing that we will do is called separating our variables. So we're going to make sure we have a y and dy together on one side, and we're going to have our x and dx on the other side. So that's going to be us just multiplying both sides or crisscrossing here. So y dy equals 2x dx. That's going to be our separation of variables. When we do our free response questions with this is considered 1 point. Now your next line that you start, you need to integrate both sides. So we have the integral of y dy equals the integral of 2x dx. And you would integrate just like you are used to integrating. So we would take the integral of y dy, well that's going to be 1/2 y squared equals 2, and then here we're going to integrate, and so we're going to get x squared over 2, and then we're going to have our plus c, and here simplifying some we have 1/2 y squared equals x squared plus c, and then to finish this off we will need to solve for y, so we would multiply both sides by 2. Y squared equals 2x squared, and 2 times a constant value is still a constant value, so we don't have to worry about filling in anything from there. And then we would take the square root of both sides. So our original equation was plus or minus square root of 2x squared plus c. And that's as close as we can get right now to finishing out the problem. Okay, so here for number 2, same process again, not going to change. So we will do some separation of variables. So it looks like our dx will need to come over here, but our y squared would need to go in the denominator. So we would have dy over y squared equals dx. And again, after we have our separation of variables, we will integrate both sides. And I'm going to go ahead and flip this up and make that y to the negative 2. dy equals the integral, and that dx is really the same thing as 1 dx, so that might make it a little easier to see. Here when we integrate, we're going to get y to the negative 1 divided by negative 1. And let's see, that's going to be equal to x plus c. And again, here we do solve for y the best we can, and I'm going to move our negative over and go ahead and flip, so I have 1 over y equals negative x, again plus c. And here solving for y, one way to think of this is you can multiply this whole side and this other side by y. So that's going to give me 1 equals the parentheses negative x plus c times y, but then we will go back and divide both sides by negative x plus c. And so we're going to be able to solve for y, and notice here we're going to end up with y equals 1 over negative x plus c. And that again is going to be as far as we can go with that problem. Okay, again, same process. We need to separate our variables. So here we're going to have 3y squared dy equals, and we're going to have x plus sine x. And let's see, all of that is going to be times our dx. All right, and again, once we have that, we will integrate. So I'm going to integrate 3y squared dy equals, and then integrate over on this other side, x plus sine x dx. And then here, when we integrate, remember we can move the 3 out. We're going to add 1 to the exponent and divide. And then over on this other side, same process. We add 1 to the exponent and divide. Plus, and if I integrate sine, then let's see, what do we get? Let's go back through. We have sine, cosine, negative cosine. And if we integrate sine, we're moving up this chain. So we're going to get a negative cosine, excuse me. Negative cosine x, and then plus c. And let's see what we can do here in our simplifying. We're going to have y cubed equals, and that's 1/2 x squared minus cosine x, and then plus c. And then we do need to take the cube root of both sides. So it looks like we have y equals, and you can leave this absolutely disgusting over here. Cube root of 1/2 x squared. Don't try to do any other simplifying. You're not going to gain any extra points by going through all that simplifying. So leave your answer just like that. Okay, so over here, number 4. A couple of ways you can do this one, especially with this 4y. If you want to just move the y, you can, and then move your dx up. So you're going to have dy over over y, sorry, there's a neck, equals 4 dx, and then integrate both sides. So if I integrate, I'm going to have the integral of 1 over y dy equals the integral of 4 dx. Now this is going to be what we've just talked about. When I integrate 1 over y, that's going to be the natural log, the absolute value of y, equals, and if I integrate 4 dx, I get 4x plus c. And this is where it gets a little tricky here. We have to remember that natural log was the same thing as log base e of y equals, and let's see, let's go ahead and keep that absolute value, equals 4x plus c. And this goes back to solving those logarithmic equations. And this is a process we will need to remember how to do for several problems. We're going to say, because we need to solve for y, so y is going to be equal to e raised to all of that other side, 4x plus c. Now notice all of that's equal to y. E is always positive. It's 71828, yada, yada, yada. So it's always positive. So we don't have to worry about our absolute value anymore. And here to simplify, this we need to keep in mind is e to the 4x times e raised to the c power. Because if I multiply with like bases, I would have added those exponents. So to separate this, this here always goes to, well, e to the c power, that's still a constant, times, and then e to the 4x. And again, there's no plus c because that c is built in here. And again, does it always turn out to be this way? 99% of the time, yeah, it does. Okay, let's move on to the next problem. Okay, this problem is very similar to what we just looked at. So again, separate your variables. So if we separate these, I'm going to move here. This k is just a constant value. So I'm going to move y down here with my dy, and of course dx up here. So I'm going to have dy over y equals k times dx, and now I'm going to integrate both sides. So I have 1 over y dy equals the integral of k dx, and you can think of this k as any number. So when we go through and we do our integration, again we'll have the natural log, absolute value of y, equals kx plus c. And just like before, we have to remember that ln is really the same thing as log base e, the absolute value of y, equals kx plus c. And now, just like with the previous problem, we're going to raise both sides to that e power. We're going to say y equals, and to remove that log, you're going to say e raised to this entire other side. That becomes the exponent for e. And then we can simplify that a little more, because we're going to have e raised to the c power. That is always some constant times e to the k times x. And again, that's always going to be the case for those. Okay, moving on to number 6. Again, very similar process. Not going to change much here. So again, we're going to move our x's and y's. And so it looks like we're going to have dy over y equals x dx. And again, after we separate, we integrate. So 1 over y dy equals the integral of x dx. And again, we're going to have the natural log, absolute value of y, equals, let's see, x to the second divided by 2 plus c. And again, just like before, ln, that's the same thing as log base e. So we're going to say y equals, and it's going to be e raised to the x squared over 2 plus c. But then we need to fix that plus c. We're going to say that's y equals e raised to the c power is again some constant times e to the x squared over 2. Now with these types of problems, we are going to find a solution to these differential equations. And notice how we have this written differently. Here we have what's called an initial condition. So we're no longer going to be just adding c, but we're actually going to go back and plug in. This is really an ordered pair, 0, 1. And we're going to plug that in and find a value for c and actually find what the equation was that I took the derivative of. So again, we start back, and this with e to the negative t is kind of weird. We can rewrite that to be x over e to the t times dx over dt equals 1. And again, we would want to rearrange this. We're going to want to separate our variables. So notice x and dt, I would keep that together on one side. And let's see, x and dx. But then notice e raised to the t power and dt, both in the denominator, we're going to move those up to the other side. So I have e raised to the t power and then times dt. So now we've separated our variables. That's going to be a point for us. Now we're going to integrate. So we're going to have x dx equals the integral of e to the t dt. And so we're going to have 1/2 x squared equals, and if I integrate e to the t, I get e to the t plus c. And now here, again, this is normally on a free response with the slope field. That's going to be an additional couple of points because you will successfully integrate and you will remember to add c. I'm telling you now, you're going to remember. And now let's go back to our initial conditions here. We're given 0, 1. So we are going to come back down here and we're going to substitute in 0 and 1 into our equations. And so we're going to see what we end up with. Okay, so let's substitute in 0 and 1. So I'm going to have 1/2 times 0 squared equals e raised to the first plus c. And so here we will solve for c, and that's always the case for these. You need to find that value for c. And so here I have 0 equals e plus c. So that tells me that c has to be equal to negative e. And now that you've solved that, you're ready to go back and you're ready to write your equation. And here's where students always wonder, well, where in the world do I put that c value? After you have it solved, we are going to pull this equation down, and that's what we plug in our c to. So we have 1/2 x squared equals e to the t power minus e. And now we would solve for x, so we're going to multiply both sides by 2, and we'll take the square root. So x equals plus or minus the square root of 2 times e to the t minus e. And that's going to be our final equation. Notice we were able to find a particular value for c. Okay, moving on to the next equation. Again, same process. We do need to go through and separate our variables. That's always important to get that point. So let's see what we can do here. Let's see, we can crisscross here. So I'm going to have xy dy equals 1 plus x dx. And we still haven't separated our variables. We've got to deal with that x. So we're going to divide both sides by x. So I have y dy equals 1 plus x all over x dx. Now we've separated our variables. Now we're ready to integrate both sides. So I'm going to integrate y dy, and we're going to integrate 1 plus x all over x dx. And let's see, this integral over here on this other side, this is going to be one of those where we divide it up. You need to think of that as the integral of 1 over x plus 1 dx. That's going to be a good way to think of it. So once we go through and we do our integration, let's see what we end up with. So we're going to have 1/2 y squared equals, and it looks like we're going to have natural log absolute value of x, because we're integrating 1 over x, plus x, and then plus c. Okay, and let's see, now let's see if we can't solve for c, or we can go ahead and solve for y, but it's a lot of times, to me, it's just easier to go ahead and solve for c. Now we were given the ordered pair 1, -4, so I'm going to plug in 1, -4, and let's see what we're going to get. So we're going to have 1/2 times -4 squared equals the natural log absolute value of 1 plus 1 plus c. So let's see, that's going to be positive 16 times 1/2, so that's going to be 8 equals natural log of 1, that is 0, plus 1 plus c. So it looks like c is going to be equal to 7. So now that we've solved for c, we go back and we find our equation that we had before we solved for c, which is right here, and we pull that down, and we're going to plug in this value. So I have 1/2 y squared equals the natural log absolute value of x plus x, and then we found that c is going to be 7. And here again, we can leave all of this pretty messed up. We're going to solve for y, but in that, remember, we would multiply both sides by 2 and then take the square root. So I'm going to have the square root of 2 times, and just rewrite all of this. And again, it is quite okay to have all of this. It's absolutely disgusting mess. Leave it just like it is. Oh, got to close my parentheses.